So hello everyone, welcome back to another particular lecture series of our Reagent Chemistry course, and this is a class 14. So in our previous discussion, we have completed all the reduction reactions. So today we'll begin with our discussion in the organometallic reagents. So in organometallic reagents, basically we are focused on four different organometallic reagents here. One is the Grignard reagent. This is a magnesium based organometallic reagent. Then we are talking about the Gilman reagent. This is the organocopper mediated organometallic reagent. Then organolithium, that lithium based, and organoboron, that boron based organometallic reagents. So we initially start our discussion with the Grignard reaction. This is a very famous organometallic reagent. So Grignard reagent are highly reactive organomagnesium compounds that used for nucleophilic addition to carbonyl groups, enabling the formation of alcohols. And the structure of the Grignard reaction is this: R-MgX, where Mg is our magnesium, X is the halogen, and R is the alkyl group. And when actually the Grignard reagent react with the carbonyl compound, this R actually attacks. This R actually acts as a nucleophile, and the nature of the nucleophile is the hard nucleophile. We just look about some kind of preparation of Grignard reagent, because this is something important for exam purpose and also for the general information purpose also. So how a Grignard reaction can be generated in the laboratory medium? So Grignard reagents are basically prepared by reacting organic halide, that is the RX, with magnesium metal in an anhydrous ether solvent, such as diethyl ether and tetrahydrofuran. And here it is also written that the reaction occurs under an inert atmosphere to prevent moisture and air from reacting with the reagent. And then after that, it will form the Grignard reagent. So this is the preparation reaction where the alkyl halide react with the magnesium in ether solvent to generate our Grignard. And Grignard reaction is actually prepared in an in situ format. So then we are talking about the preparation of Grignards. So as I already discussed, that the alkyl halide that react with the magnesium in dry ether solvent to get Grignard. And it is an example of an oxidative addition, because here the magnesium is in the zero oxidation state, but in the form of Grignard reagent, magnesium is the +2 oxidation state. So it is called the oxidative addition. And since it is a -2, that means the halogen is -1, and here the alkyl group is also in -1 oxidation state. Okay. And it is the example of oxidative addition. And the X is the halide group, bromine, chlorine, iodine. And fluorine is not actually used in the Grignard synthesis. These three halogen are normally used to synthesize Grignard. And rate of addition is the 1 degree alkyl halide are much more reactive towards the Grignard synthesis over the secondary halide or tertiary halides also. And here I already discussed that this R that is actually coming from alkyl halide. So this is initially the del positive, and after getting the Grignard part, it is generating the del negative characteristics. And this R minus is acts as a nucleophile. And here a reversal of polarity observed between this particular alkyl part. Initially it is on a positive state, but in the Grignard reaction it acts as the negative oxidation state. And this is called the Ampolang reagent that we'll discuss in the next slides. Here is also written that reversal of polarity observed, that is called the ampolar system. So this is how we can prepare a Grignard. Like if there is a competition is there between bromine is also there, chlorine is also there. So bromine is much more reactive towards Grignard synthesis. So in presence of one equivalent, it will initially this Grignard has been generated, but if it is an excess, not one equivalent, if it is an excess amount, that magnesium present in the excess amount, then both side of Grignard has been synthesized. And how to store the Grignard reagent? Grignard actually stored in the inert atmosphere such as nitrogen or argon in tightly sealed dry glassware to prevent exposure to moisture and air. and they are actually kept in a cool and dark place to maintain stability. Now let us talk about the different reaction over the Grignard reaction. So in the description box, I will put a handwritten notes about the Grignard reaction. So go through it. And here basically a Grignard can be react in the two different pathway. One is the acid-base reaction and another is the reaction with carbonyl compound. So in the case of acid-base reaction, basically if this type of system is there, ZA, so Z equal to RO, PHO, RS, RCC, RCOO, RNH2. So then it will actually, this particular hydrogen is been abstract and it will generate the alkane and the corresponding residue is generated. Also, alkane halides, these things are react with the magnesium and water to generate corresponding alkenes. This also reaction can be possible. This is also a side reaction. If the Grignard synthesis pathway, if there is a moisture present there, then this type of side reaction can be observed. For example, here you can see that this is the compound and here the magnesium and water is there or moisture is there. So basically no Grignard formation takes place. Rather, this type of compound has been generated. Similarly, here is also the same. And in the case of 1,2 and 1,3 dihalides are not react with Grignard. So this is something that you have to remember. Next, we will talk about Grignard reaction with carbonyl. This is the very important, like mostly in the exam purpose. This part is actually important for your CSR, NET, GATE, JAM examination. First of all, we need to learn about that Grignard. It is a hard nucleophile. Like this is the Grignard, there is the R-MgX. So now this particular R acts as a negative charge and this is actually the nucleophile. And this is the hard nucleophile due to presence of the magnesium because magnesium is also hard. So that's why it will favor 1,2 addition product. Because here you can find here this carbon in carbon, this is also in a hard center and this is also in a hard nucleophile. So hard-hard interaction is observed and we got this 1,2 addition product. And this is the most normal reaction in the case of Grignard. Now there is a certain reaction is there that how a Grignard reagent actually react with different compounds. So basically if it is react with the CO2, then it will form an acid part. If it is react with acid chloride, so 2 equivalent of Grignard is actually consumed in with 1 equivalent of acid chloride. So first R1 is actually attacked here to kick out this particular chlorine. Then it will again form carbonyl compound. So another equivalent of R1 actually attacks here to form this type of alcohol, tertiary alcohol. So this is the final product. Similarly, for the ketone, there is a 1 equivalent of Grignard reaction actually react to generate this type of tertiary alcohols. For the case of aldehyde, it will generate a secondary alcohol and here is also 1 equivalent of Grignard reaction actually used. In ester, there is a 2 equivalent of Grignard reaction reagent has been used for completely react with the 1 equivalent of ester. First, this OR actually kicks out and then another particular R1 actually attack to get this particular tertiary alcohol. And for the case of amides or the Werner amides, this is called the Werner amides. So here the reaction is stopped in the ketone center, but in the case of excess Grignard reagent, then it will go to the alcohol state. Similarly, in also Grignard react with the cyano group to generate their corresponding ketones, and for epoxide it will the Grignard is attacked from the less hindered side, so attack from here and after epoxide ring opening we got this type of compound. So this is the overall reactivity of the Grignard reagent. And also in the case of alpha beta unsaturated carbonyl compound, and so we know that this particular carbon in carbon is the hard center and this particular 1,4 center is a soft center. And since the Grignard actually yields the R minus, it is the hard nucleophile, thus that particular nucleophile attack in the 1,2 position, and this particular product is major and no 1,4 attack takes place. To maintain hard-hard interaction, Grignard often show 1,2 addition. But if here this particular area, that a 1,2 addition, here if a bulky group present, such as BHA, BHD, this type of group, then the somewhat this particular addition getting hindered because of this particular steric reasons. So in that particular case, sometime 1,4 addition is felicitated and we got this type of compound. So this is a very exceptional case, but in the case of mostly in the case of alpha beta unsaturated carbonyl compounds, 1,2 addition takes place in presence of Grignard reagent. So with this, we have to end this particular lecture. In the next lecture, we are talking about the different organometallic reagents, mostly in the Gilman reagents. So thank you for listening.